All right, I think we can start. Hello everyone, thanks for joining this session on distributed zones with Red Hat OpenStack. I'm Gregory Charot, I'm French, local here. I'm the product manager for storage with OpenStack and OpenShift. Obviously, today we'll be focused more on OpenStack, and I have the honor to co-present with
Yep, Soumaya, MSALLEM. I'm partner technical account manager. I am in charge in OpenStack customers and partners in EMEA region.
All right, thanks for co-presenting with me. All right, so before we dive into the specifics of this architecture, I'd like to give a refresh on our new version and how we deploy OpenStack in our 18 version, because that's changed quite a lot. In the previous version, we used O to deploy OpenStack. It had this flow, to be honest, but now we switched to a Kubernetes native model to deploy OpenStack. Right, so you have some sort of very, very high level summary here. So on the left, you have the Kubernetes cluster, which in our case is OpenShift. So that Kubernetes cluster is responsible for deploying both the control plane as native pods, right? It's not a container running alone or rogue. It's really a pod running on OpenShift, and we deploy all the OpenStack control services. So Cinder API, Nova API, the database, RabbitMQ, you name it, everything control plane is running as a native pod here. It's also used to deploy the data plane here. But obviously, data plane is on bare metal nodes. It's not a worker per se. It's a rail node here, and it will be used to become a compute, right? And Kubernetes provision the node, and it also deploy all the OpenStack data plane services, such as Nova Compute, right? So everything orchestrated here. Control services as native pod. Obviously, all the data plane is still running on regular bare metal. Now that the scene is set, we can dive into a more advanced architecture. So what is it architecture? What's the goal? The goal is to deploy an OpenStack environment across multiple failure domains, or zone, that's shorter, so that one zone entire failure would not affect two others, right? The goal being, if I have a workload, I want to spread the workload across 3 zones, so that if one zone goes down, hopefully my application is well done and it can survive. This mimics what major public clouds are doing, like you remember the US East 1, East 2, East 3 kind of approach they have. We're trying to mimic that, right? What a zone is, it depends entirely on the operator or the architect. It can be a rack, it can be a row, it can be a floor, or it can be an entire data center, depending on the failure level of resiliency you want. Obviously, if it's between sites, you have more resiliency than if it's in a rack. But it's up to you to decide what a zone is. I will assume sites in that preso, but it's up to you. So how does that work? We have to stretch every layer of the deployment for that to work, right? So the control plane here, that's both OpenShift, right? Remember this slide, right? So we have to stretch the control plane of OpenShift and the control plane of OpenStack running on OpenShift. That's one. And then on the data plane, we need to do the same thing. We need to dedicate storage and compute in each zone, so that if it fails here, it's not impacted in the 2 other zones. So how do we approach this in this preso? First, hardware design and placement. How do we do that? The OpenStack features and configuration we use, and how we deploy that. All right, heavy slide. So that has a view of a more low-level view of what I just presented. So as mentioned, we want to split the environment in 3 zones. Why zone? Because you have quorum, especially with MariaDB, the masters for Kubernetes and so on, so you need 3 zones. Here on red, you have the workers, the OpenStack control services here, and we replicate that across the 3 zones. So we want one Kubernetes master per zone. Obviously, if one fails, we want to be alone in that zone. We want one set of Kubernetes workers per domain, right? The one that are running the OpenStack control services. We want more than one, obviously. If one fails, we want to be able to recover the pods on another worker of that zone, so we don't have some sort of split zone traffic. What else? Data plane. So data plane, same thing. We want to isolate as much as we can so that if something goes wrong in one zone, it doesn't impact the other. So we have a set of computes in each zone. Same thing for storage. If my storage goes down here, I don't want to have some sort of cross attach so that this VM goes down just because this storage went down. All right, if we zoom in a little bit, color is crappy, excuse me. If we zoom in a little bit, so you see your workers here on green, right? And all the control services are running on these workers. So what is important is, as I said, I have multiple workers per zone. So if one goes down here, the service that are here can go in another worker. That's a good idea. We put 3 here, 2+ is recommended. In terms of soft isolation, we rely on AZs, so availability zone in OpenStack. Those are Nova AZs, Cinder AZs, Manual AZs, Neutron AZs, Octavian AZs, so that they are isolated from a logical point of view. What else? The service placement is important, right? We have some services like the APIs that are common to the environment, right? The API serves all type of requests. Like Nova API is global to the cluster, so we want the Nova API services to be spread across the zone, right? One Nova API here, and one here. Some services, on the contrary, are local to zone. We'll see that. For example, Cinder Volume. That Cinder Volume is dedicated to a local storage backend. And we want that service to run on the same zone. We don't want cross traffic, right? That will be done. So that's the high-level view. We'll dive into the specifics, starting with storage, and Soumaya will go over more networking details. First, with the storage backends. So we want, as I said, a dedicated storage backend per zone, so that if one fails, obviously, it doesn't impact the others. In this preso, we focus on Ceph. We have support for third-party providers. It can be hyperconverged or external, depending on the needs. What is important to note for Ceph is obviously all the pools are dedicated to the zone. So Novas, Glen, Cinder, CephFS, you name it, are dedicated to the zone. So you have one Nova pool here, and one here. Same thing for Cinder. And the computes are consuming their local Ceph cluster, right? We don't want a compute here to consume Ceph here. Same thing for Resiliency. The same rule applies if you want an app, a Pure, a Hitachi, you name it. Same thing, one backend per zone. All right, let's go more software now. So Cinder, how do we approach Cinder? So from a user perspective, you're going to create a volume and specify the zone or the availability zone when the volume wants to be provisioned, right? We set, as I mentioned, one AZ per zone, and that zone should match the Nova AZ name actually. The API service, as I mentioned earlier, everything that is API, usually it's global to the cluster, so we want a Cinder API pod per zone, right? So here it's in worker 1, but it can be one here, and one here, right? Doesn't matter. Just one per zone, so that if you put 3 here and it goes down, you have to reschedule that. That's a mess. So spread eventually the common services. Scheduler, we have one, and there is no zone affinity. Why one? We can discuss that at the end of the session if you want. But that one is not bound to a zone. Volume service, on the contrary, it's one per backend. So we have one Cinder volume service running per backend, and that service needs to be scheduled in the same zone as the storage. So for example, here we have Cinder volume AZ1 that will be configured for the Ceph cluster that will be sitting here. And it can be only scheduled on that zone. You don't want some weird cross-zone traffic. Cinder backup is a bit weird. We are going to improve that, but for now, we are limited to one target backend for the backups. So you need to choose one, right? Which one is going to be, we don't know. Here we put AZ1, and obviously since the backup target is here, we put all the Cinder backup pods here. we're going to improve that by having a set of Cinder backup services per zone that can each point to their respective cluster, or you can configure it to back up data elsewhere, like outside your environment, which can be a good idea. Everything that I mentioned applies to non-Ceph backends overall, right? Besides the Ceph pool and so on, but that's pretty much the same regardless of the backend. Now glance, bear with me because that's a bit more complicated. All right, so glance for images. We leverage Glance multi-store, so for the sake of time, I didn't add my Glance multi-store slide, but see it as a multi-backend for Glance, pretty much, right? So we use one store per zone. Same principle as Cinder volume, one Glance store per zone. It's RBD because it's Ceph, but if you're using non-Ceph backend, we would store your image with Cinder, right? That's here forever. We have 3 Glance API external to serve the external requests. We have 3 internal default API. We split external and internal because of a security issue there is in OpenStack. It's fixed in Flamingo, but we have to split the two. But that's not enough. We need Glance APIs to be local to the zone so that it serves only that zone. Because otherwise you could have some cross traffic, right, for serving images or uploading images even. So what we do is the Glance API internal default is just there to serve the default request because there is a default store if you don't mention anything. When you upload an image, you say, I want it in that site. If you don't mention anything, it will go to the default. Now we have the Glance API here, right, and here. Those two are dedicated to that zone, so to that Ceph cluster, ultimately, right? And those two are actually exposing a dedicated VIP, right, endpoint to the OpenStack computes that are here. So why do we do that? Is because Glance is not AZ aware. There is no AZs in Glance. So we need a way to tell the compute, okay, point to that endpoint, and that will be your local store, right? Otherwise, if you point it to a Glance, or general Glance, it doesn't know where to go from there. It will give you the default. So that's why we also have these 2 internal Glance API. All right, now on the storage part, the Nova part, excuse me. How does that map? So as I mentioned, we use the local Ceph for the computes, and we use the local Glance store. We want to avoid cross-zone traffic, again, for isolation. So since it's Kubernetes now, every configuration are Kubernetes YAMLs with Kubernetes objects. So what we do, it's a config map, it's a regular config map, Kubernetes config map. The Ceph conf that we give to Nova is the one that is dedicated to that zone. Here it's zone 2, right? And here is our little endpoint override we just discussed. So we say Nova for Glance, look at this endpoint. In that case, that would be site 2 here, this one. So that's the arrow here. So that when Nova asks for an image, it will go to that specific store, not another one. We can walk upstream to make Glance more store-aware, but that's not the case today. All right. Okay, cool. Manila. All right, Manila is easy. It's pretty much the same thing as Cinder, right? So tenants, you choose how to deploy provision their shares. So you specify the AZ, same as Cinder. We use Manila AZs, no surprises here. In case of Ceph, we have one CephFS backend per zone. Same thing, we don't want to have cross traffic or if something goes wrong in one zone to impact the other. Same as Cinder API, 3 external Manila API, they are shared across the entire environment. Scheduler, we can do 3 in that case, so we have, but they are common to environments, so we have 1 per zone, where it is here, right? 1 per zone. And for Manila share, same deal as Cinder volume, one per zone that is dedicated. So that Manila share has only the configuration to talk to that Ceph cluster. And something I forgot to mention is we disable cross-AZ attach in Nova to avoid a VM here to attach in volume in another zone, which can be a problem, especially if you have latency, right? In Manila, that's not possible. So the only thing you can do is nicely ask your network admin to put ACLs or something, but that's not something we can do with Manila today. And the same approach works for a non-Ceph backend if you have Dell, Pure, or Onera. Same approach. Now, from a user experience, well, for the CLI user experience, simple boot from volume example. I import my image to site 1 and site 2 here. So that's a COS image, and I specify the stores here, right? So after this command is executed, your image will be in site 1 store and site 2 store, right? Next, just for the demo, you can, once the image is copied, you can copy the image across stores. You don't need to re-upload it. So after this command, the image will be available in all 3 zones. And there is a upload to all zone -- thing. Create the image create the volume from image on site 2. That's fairly common, right? Nobody's surprised here. And book the VM on site 2. So we specify the AZ here and the volume ID. All right. Before I pass over to Soumaya, I keep repeating how we need to schedule services. It needs to be balanced and spread across the workers. Some services need to be pinned to a zone. How do we do that? So we leverage Kubernetes technology here. We define zones in OpenShift itself. So that's the regular OC label node. Nothing, no black magic here. And each worker, so you have 9 here, 3 per zone. We tag them with the topology Kubernetes IO, zone equal whatever. In that case, it's a good idea to be meaningful. Same thing for zone 2 and same thing for zone 3. Once that's done, we define the topologies themselves, right? So we have one topology for spread pods across the zone. So I want 1 per zone or 2, depending on how you scale, right? But at least I want 1 per zone. That's the default spread. 1 here, max Q1. We want 1 per zone maximum. And then we have one topology per zone for the services that are meant to be bound to that zone, right? Like Cinder volume, right? I want Cinder volume in zone 1. How do I do it? Zone 1 node affinity. I reuse the key I just mentioned here. Value equals zone 1, right? Same thing for 2 and 3. And then when you configure your OpenStack services, right, with YAML, it's very simple. So for example, Cinder API times 3, I want 1 per zone, right? Cinder volume zone 1, I want to be here, not here, right? So how do I do that? Cinder API on the top, replica 3, so you have 3, and then the topology ref will reuse the name I just explained here, right? So that you're sure that there is 1 per zone. And this is actually a default, you don't need to put it in your config. Just explicitly mention it, but that's default. Now for Cinder volume or any service that requires pinning, then Cinder volume, that's how you configure Cinder volume. For the Cinder volume on zone 1, obviously I want the topology zone 1 node affinity that I just configured, right? Same thing for node 2, same thing for node 2, same thing for zone 2, and same thing for zone 3. And that's how you pin services to zone. Thanks, Kubernetes. I like you. All right, I'll pass it over to Soumaya for Nova sales and networking.
Thank you. Okay, so I will introduce Nova Sales. In case of large deployment of OpenStack, we can divide compute nodes into different groups, which are cells, what we call cells. So each cell will have dedicated RabbitMQ cluster and dedicated Galera cluster and specific compute services related to the cell. Okay, so doing this, we will gain in scalability. So instead of having only one RabbitMQ and Galera used for all the OpenStack cluster, we separate dedicated RabbitMQ and Galera for each cell, and this way we have more, we gain in scalability, right? So each RabbitMQ will only manage the traffic and the communication of the cell in question, and each Galera cluster will only store information related to the dedicated cell, okay? And eventually compute nodes related to the cell. So as you see, for each AZ here, we represent the AZ as a Nova cell. On top of that, we have cell 0, and the cell 0 contains some Nova services which are not by cell, which are stretched across on cells, right? So we have Nova API, we have Nova scheduler and superconductor, and we have a database which are central, containing all the information of all OpenStack or Roseau services. So this is the concept of cell. Okay, then I will talk about networking in Red Hat OpenStack services in OpenShift. So we rely on network isolation. So for each network traffic, we have separate network, okay? For each traffic type, a separate network. So for example, control plane, the control plane will manage the access and the configuration of compute nodes, okay? So it will be used to SSH to compute nodes and deploy them and configure them. Internal API will be dedicated for the communication between OpenStack services. External network is dedicated for external reachability to the virtual machines inside OpenStack. Tenant is dedicated for communication between virtual machines. Storage is used for access to the storage. Storage management is more for the management of storage in itself. For example, replication traffic or accessing storage bay to manage storage. And Octavia is the network used for load balancing and Amphora traffic related to Octavia. So this is the network isolation part of things. And now if I back to distributed zone architecture, which is our topic, you see for each zone we have dedicated subnet for each network, right? So for example, control plane, we have a subnet related to control plane for each zone or availability zone. So this way we gain in segregation, in performance and security. Then a bit about the physical connectivity and the fabric layer of things. So in distributed zone architecture, we have routed, spine, and leaf architecture. As you see, 3 zones, L3 connected through BGP. All Roseau routes should be advertised to leaves, then to spines. From configuration perspective for the control plane, we rely on OpenShift capabilities to do the configuration. For example, we leverage NMState to configure the worker nodes with the isolated networks. We rely on MSALLEM operator using BGP mode, and we use OpenShift routes to expose the external routes of OpenStack or the external endpoint of OpenStack. Then Octavia, so this is the last part of the presentation. For Octavia, so as you know, it is a service used to manage load balancing of OpenStack. So we rely on what we call Amphora as virtual machines, used as load balancers. And then we have Octavia with a control plane, which will manage the Amphora located inside our compute nodes. So inside distributed zone, you see that we have segregated Amphora by zone. Okay, we have a network LB management by AZ, and we have our control plane managing the dedicated Amphora inside the AZ version. So you see, as mentioned by Gregory, we have zones for Octavia, so each zone will be managing the Octavia of and Amphora of the zone in question. So this is the architecture used in Red Hat OpenStack. And thank you.
That is it. On time. If there is any question, yeah. Oh,
Keystone.
yeah. Another Keystone guy. I don't like Keystone. It's regular Keystone, to be honest.
So it's it's running. Where is it running in the end of the day? Because as far as I know, you can only have one Keystone instance, even if you have multiple cells.
I'm the storage guy. Junker. The services, we can spread them, but I don't know.
Where is Keystone running? Because as far as I know, you can only have one Keystone per complete OpenStack installation. So even if I have multiple cells, I still have more or less my single point of failure.
Right, so in that case, that would be like a Cinder scheduler. We'll schedule it anywhere, and if that fails, we can reschedule it on another zone, if that's the case. That's what we do with Cinder scheduler. Yeah.
How utility zones and cells relate? Because I usually think about cells like regions, but in your schema it didn't seem that way.
So OpenStack region, go ahead.
Yeah. So the question is how the cell is managed, right?
How
what is the
cells
concept
and
of-
availability zone? You have
Yeah.
many cells inside one availability zones, or vice versa?
Yeah, so you group a number of compute nodes inside one cell, and this way you manage this cell
Okay.
entirely and
And
separate
this
from-
cell is then can be separated in availability zones.
So in my case, it's mapped to the same availability zone.
Okay.
So the same computes in the AZ are mapped by
That's
the
what
same
serve
cell.
does as well.
Okay.
Cells are more for scalability, like a big deployment,
Yeah.
you want to isolate some of the database and messaging to a specific set of compute. AZ are more logical to schedule things.
Another question. Is Octavia over OVN supported or only Amphora?
OVN is not, until now we don't have OVN supported with Octavia. So it's something that we are working on internally, but it's not yet supported.
All right. Yes.
Another question regarding to the cell model. You have a cell 0, like Bob, is the root cell. The API services, maybe I missed the part, they still need a RabbitMQ. Is the RabbitMQ spread across the zones in the cell 0?
Cell 0, there is a dedicated RabbitMQ for cell 0 for all OpenStack services.
Okay.
And then you have one by cell for the information related to the saving question.
I know that's, yeah, that's okay, but I missed the part that is the rapid MQ and the cell 0 dedicated, because when you spread the cell, the rapid MQ for the cell 0 across these 3 cell zones, and each zone is a data center. In case the latency between these data centers is too high for a rapid MQ cluster, is it possible to deploy that cell 0 cluster in one zone to mitigate that? Deploy the cell 0 rapid MQ cluster in one zone.
I'll wait outside if you ask a question.
Of a data center, the latency between the sites